Hello everybody, I greet you all. Now I want to use this opportunity to show us the configuration and the connection of this our solar installation. This is actually a 7.5 kVA solar system. All right, this is Felicity inverter. When you look at this inverter, you see that it's Felicity, and when you check now, you see that this is actually our batteries. All right, we use the tubular batteries. The name of this battery is Star Plus battery, and this is Felicity inverter. And when you look up here, you see that we use two combiner boxes, and when you look here, you see that we are using two changeover switches. All right, so when you look at this installation, you see that these batteries, being 4 batteries, are actually connected in series. The reason why we connected these 4 batteries in series is because the DC input voltage of this inverter, which is 7.5 kVA inverter, is 48 volts. All right, it's 48 volts, and for it to be powered, we need to connect these batteries because each of these battery is 12 volts 220 Ah. Let's see it here, 12 volts 220 Ah battery. Each of them is 12 volts. So when we connect them in series, we will get 48 volts in order to power this 48 volts inverter. This is 7.5 kVA hybrid inverter. So what makes it hybrid is that when you look at this inverter, you see that it's actually charging with the utility supply, which is the input AC, and again the panel, which is the one that comes from the panel. You see this panel symbol here, and you see that this point is output. You see that there is input, there is output, meaning that this inverter is on. All right, when you look at this inverter also, you see that it has a port whereby it comes with PV input. All right, PV input. And when you look at this, see that there are 2 breakers here, AC input breaker and AC output breaker. And when you look here, you see that this is output, the output, okay, the output terminals whereby you connect the output wire and you connect the AC input wire. All right, this is from the battery connection. You see that this is actually 48 volts, although we have 24 volts and 48 volts the battery voltage, but here, because this inverter is 48 volts, that's why the 48 volts is dotted. All right, is ticked, meaning that this is 48 volts inverter, hybrid inverter. And this connection, the way we did this connection is that we connected the panels, and again the wire from the panel comes to this first combiner box here. And when you look at it, see that the wire from the panel comes to this and connect to the input of this DC breaker and then the surge protector. And from the output of this DC breaker, the wire runs direct to this PV input. This is the wire here. This is the wire, positive and negative, for this PV input. The reason why we connected to PV input is that the wire coming from the panel, which is the panel output wire, should be connected to this PV input, because this is hybrid inverter. It has inbuilt MPPT charge controller. And again, when you look at it, you see that the AC input, all right, the supply from the utility supply, which is the AC, you see that there is AC source, comes through the AC breaker and AC surge protector, then passes through the display, this voltage monitor display. You see that it's displaying 219 volts, meaning that the voltage that's coming from the utility is 219 volts, and it's being used to charge these batteries through the AC input terminals of this inverter, which is this AC input terminals of this inverter. Then the output wire from this inverter, which is the output wire from the this output terminal of this breaker, this AC output breaker, the output wire goes through this combiner box down to the changeover. And when you look at this changeover, we use 2 changeovers to achieve interlock connection in such a way that when utility supply is working, an inverter will not be powering the house, and when the inverter is powering the house, the utility supply will not be powering the house. So we use it to achieve that interlock connection, and this is how we connected